Let's talk about density. This is going to be your lab over this week. The concepts for this lab are actually surprisingly easy to grasp, I think, because there's really only one equation that we need to worry about, and it's going to be this one here, where we say that the density is going to be equal to the mass of the object that we're talking about divided by the volume. Okay, so looking at this equation, this tells you basically what the definition of density is. It's the amount of mass or the amount of stuff that I can fit into 1 unit of volume, of 1 unit volume unit. So something like iron is going to have a much higher density than styrofoam, because if we compare the same volume of iron and the same volume of styrofoam, the iron is obviously going to weigh much more, okay? Because you can fit a lot more material or a lot more mass into 1 unit volume of iron than you can for styrofoam, right? So we don't want to get density confused with weight, okay? This goes back to the class example: what weighs more, 1,000 pounds of feathers or 1,000 pounds of iron, right? They weigh the same, right? Because they're both 1,000 pounds. However, it takes a lot less iron to get 1,000 pounds than it does feathers, because iron is a lot more dense. Okay, so you don't want to avoid getting density confused with weight. Okay, so just because something is more dense doesn't necessarily means it weighs more. Okay, because you have to look at the amount of stuff also. Now, in order for something to float, it has to have a density that is less than whatever the material that is sitting in. So typically when we're talking about things that are floating, we're talking about water. So the density of water is going to be 1 gram per centimeter cubed, right? Or you can think of it as 1 gram per milliliter, because milliliter and centimeter cubed are the same thing, but we typically use milliliter when we're talking about water. So for something to float in water, it has to have a density less than 1 gram per milliliter. Another way of thinking about this, other than its density being less than, is that whenever an object is in water, so here we have some water, we have our boat. For this boat to float, yes, its density has to be less than water, but also the weight of the water that it pushes out of the way has to be equal to its own weight. And this is due to something called the buoyant force. So anytime we have an object sitting in water and it's floating, there's going to be a buoyant force pushing up on it that we're going to call FB. And this buoyant force is actually going to be equal to the weight of displaced water. And what I mean by displaced water is the amount of water that would have been there if the boat wasn't there, okay? And then it's going to obviously be pushed down by the force of gravity. All right, so if this object is floating, these two forces are going to be equal to each other because it's going to be in equilibrium in the y direction. So that means the weight of the displaced water would have to be equal to its own weight. And this is what we call Archimedes' principle. Okay, so Archimedes' principle states that in order to float, the weight of water displaced has to be equal to its own weight. So when we're building boats, we want to, because steel is so dense, and typically we're building boats out of steel, and we want to make sure that our boat is built in such a way, in such a shape, that it's pushing enough water out of the way that the buoyant force is going to be equal to the force of gravity. Okay, so this is very important, this Archimedes principle, which is another way of determining whether or not an object is going to float. Okay, so what we're going to show in this lab, the first part of the lab, you're just going to be calculating the density of various materials. So it's going to give you, we're going to find the mass by just directly taking the mass using the triple beam balance. The volume is going to be calculated because they're going to be typical shapes like spheres and rectangular prisms, things that we know how to get the volume of just by measuring the dimensions. So you're going to calculate the volume and then divide the mass by that volume to find the density of various shapes. And then in the next step, we're going to demonstrate this Archimedes principle. So we're going to be actually building a boat out of clay and making sure that the weight of the boat is equal to the weight of the water displaced. Okay. And so what you'll see here next is a demonstration of the various explorations and the experiment for this lab. Okay guys, let's go ahead. We're going to start with your exploration procedure, and then if you'll just follow along in your book, we're going to go through most of the things within here and kind of show you how you would have done this lab were you able to attend in-person labs. So the very first part of the exploration involves dropping various objects into this tank of water that we have here and observing whether or not they will sink or float. But before we actually put them in here, you need to make your prediction. So go ahead and do that now if you haven't already. Stop the video and make your prediction. And what we're going to do now is actually going to head and test them. So the very first one is going to be the marble. So let's put our marble in our tank, see if it sinks or floats. It sinks. All right, next is the ping pong ball, which floats. Next will be the golf ball, which sinks. And then we have our pool ball, which is going to sink. And then we have our basketball here, our mini basketball, which you can see floats. And then finally is going to be the bowling ball. So let's drop the bowling ball in here and see whether or not that sinks or floats. And as you can see, the bowling ball does float. Okay, that one usually surprises a couple of people. All right, so that's going to be the first part. So from that, you can make your observations and then answer the corresponding questions. And that really is it for the exploration. The rest of the lab is going to be your experiment. So the very first part of the experiment involves measuring the mass and the volume of various objects and then calculating the density. So just the objects, just so you can see them. I'm not going to obviously just take the mass here and then volume here because that would be a waste of time, but those numbers are given to you in your PDF on Canvas. So the first two objects is going to be the steel ball here and the Nerf ball here. So you're going to be finding the density of these by first measuring the diameter and then calculating the volume and then measuring the mass, and then from that you can get the density. Okay, so both of these are spheres, so make sure you're using the volume of a sphere in order to calculate the volume of these objects. The next three are going to be the mass of a lead cylinder. So here we have our cylinder. All right, so make sure you're again using the equation for a cylinder whenever you're doing the lead. And our two, the next ones, the wood and the styrofoam, are both going to be rectangular prisms. In the case of our styrofoam, it's actually a cube. Okay, so use again the corresponding volumes, the correct volume equations whenever you're doing the wood and the styrofoam. Okay, so all of those, like I said, masses and dimensions are given for you. So just make sure you go through and carefully calculate those densities. The next part, object set number 3, involves finding the density of 2 Coke cans. One of them is going to be a regular Coke, and the other one is going to be a Diet Coke. All right. When we were measuring the diameter, we measured the thicker diameter here, not the diameter of the top. Okay, so an actual cylinder, right, would extend up past this point, so it wouldn't have these lips. So whenever we calculate the volume of these Coke cans, the volume that we're getting is actually going to be a little bit greater than the actual volume of the Coke. Okay, so keep that in mind when you're answering your questions later on. But what we will see is one of these is they're gonna behave a little bit differently, right? Because Coca-Cola, non-diet, has a ton of sugar in it, and Diet Coke is not going to have that same amount of sugar, so this one is going to be a little bit denser. So let's go ahead and drop them in our water now and make our observation of which one sinks and which one floats. And so hopefully you can see here the Diet is actually floating while the Coke can, the regular Coke, has actually sunk. Okay, and again that has to do with the amount of sugar in one versus the other. All right, and that'll do it for the first part of the experiment. Now we're going to go on to part B, the floating egg. I actually don't have an egg on me, but I'll explain to you what you could expect, and if you have an egg at home, you can actually try this. All right, so you would fill one of these cylinders with water. Then if I had my egg, I would take my egg and place it in here. And to get the volume of an egg, I would have to take what is the initial volume here, and then what is the volume after I place the egg. And then from that, I can get the volume of the egg by just taking the difference of the water level with and without the egg. So that's how you would get the volume. So that's already been done for you in your online PDF, along with the mass. So you can use those two values to calculate the density. Now, if your egg is new and not old, it's going to sink. Right? So what it tells you to do next is to add some salt to the water. And if you add salt to the water, you're increasing the density of the water. So you can kind of predict what might happen if I increase the density of the water and then replace the egg in. You can see, will it sink or will it float again? Okay, or will it sink again or will it float now? And that's and if we were able to do that, I guess if you're not able to do this at home, the egg would float when it depends on how much salt you add to the water. But you need to increase the density of the water such that it's now greater than that of the egg. And then the final part involving Archimedes' principle, you have a wooden ball and you'd also have clay that you're going to make into a boat. So you would fashion this clay into some sort of bowl or boat that could then float, and then you would take an initial reading of our water level in our beaker again, like we did with the egg, and then we would place our boat in the water and take a reading after. And then by the amount of displaced water, by the amount that the water raises up, will tell us the amount of water that our object is displacing. And then from that, we can determine the mass of the displaced water. And so this is how we're going to confirm Archimedes' principle, right? Because if this object is floating, it needs to have displaced amount of water equal to its own mass. So if we can see if we can place this in here and if it'll float. If not, that's fine. So you can see our I don't know if you can see actually, but it's floating in there. And so once it's floating, we would take our final reading, like I said, and then from the initial and final reading, you can determine the amount of water displaced and then compare that weight of that water that's displaced to the weight of the object itself. And so all of those numbers are already given to you in the PDF also. And so you should be able to use those numbers to then draw your own conclusions about whether or not Archimedes' principle is correct. And that would have done it for this lab. So there is lots of little parts to this lab, but all of them are kind of getting you used to this concept of density and Archimedes' principle, and trying to hopefully demonstrate those qualities to you. All right, so that will do it for today, and we will see you next week.